In this lesson video, we're going to look at a linear relationship and what it looks like in a graph, an equation, and in a table. But first we need to introduce a new vocabulary term. This term is rate of change, and it means the ratio of how y changes to how x changes. So we should know a ratio is just a fancy word for a fraction, and our fraction compares how y changes to how x changes. And this is really comparable to the unit rate, but I'm going to show you how it looks a little bit different in this example. So here's our example. Devin is saving money for a new video game. He already has $5 and he saves $6 every week. Express this relationship in the table, the graph, and the equation. Okay, hopefully you can see that this situation is a little bit different than what you've seen before because it says he already has $5 and he saves $6 every week. So it looks a little bit different. So let's start with the table because the table is always the best thing to start with. So I put 0 on here because before the weeks even start passing, he already has $5. So at week 0, he has $5. Okay, after 1 week has passed, how much money does he have? Well, he has $6 because 1 week has passed, plus the $5 that he already had. So he has $11 after 1 week. Okay, how much money does he have saved after 2 weeks? Well, it's 2 weeks have passed, so 6 times 2 plus the $5 he already had. So 6 times 2 is 12 plus 5 gives me 17. Okay, how much money has he saved after 3 weeks? Well, he saved $6 every week, so 6 times 3, but he already started with 5, so plus the $5 he started with. 6 times 3 is 18, plus 5, 23. So after 3 weeks, he has $23 saved. Now the question is, how much money does he have saved after X weeks? This line is going to help me figure out how to write the equation. So X is a variable that represents any number of weeks that have passed. It could be 4 weeks or 10 or 100, it doesn't matter. How do I figure out how much money he has after X weeks? Well, he saves $6 every week, so I do 6 times how many weeks have passed, but he already had $5. So I have to add $5 to whatever that is. And that equals the amount of money that he has saved. Now let's hurry and write our equation first. So the amount of money that he has saved, y, is equal to $6 times how many weeks have passed plus the $5 he started with. So for example, if 10 weeks have passed, then that would be 6 times 10 plus 5, so that would be $60 plus 5 is $65. Probably enough for his video game by then, right? So after 10 weeks, he would have $65. So this equation, oops, let's try not to erase it. This equation represents this relationship. Now let's take a look at the rate of change. Notice that, or remember that the rate of change is comparing how y changes to how x is changing. So from one line to the next, x is just changing by 1, so that's not going to change my fraction at all. So let's just take a look at how y is changing. So from one line to the next, how much is y changing by? We go from 5 to 11. That's an increase of 6. We go from 11 to 17. That's also an increase of 6. 17 to 23, that's an increase of 6. So my rate of change, or how y is changing, is $6 per week. And you can see that that was also shown in our problem. Next, let's graph this information. Here are the points. I have the point 0, 5, So 0, 5. I have the point 111, the point 2, 17, and the point 3, 23. So 3 up 23. Enough points for me to draw my line. And it looks something like that. Now hang in there with me one more page. Oops, I wanted to copy this first. So this question asks, for this situation, is this a proportional relationship, and how do you know? Well, remember that a proportional relationship means that the ratio y to x is the same for any line, right? So the ratio y over x, 5 over 0, that reduces to be 0. The ratio 11 over 1, that reduces to be 11. Well, it's already looking like I don't have the same ratio in each line. And so it's looking like, no, it's not a proportional relationship because these are not equal to each other. Another way that I can tell that it's not a proportional relationship is when I look at the graph. I know it's a straight line, so that means it's a linear relationship. It's a straight line, but it's not proportional because it doesn't start at 0, 0. So a proportional relationship always starts at 0, 0. And this one doesn't, so I have to say no, it's not proportional.